Geometry Lesson 18, Triangle Theorems. We're going to start by looking at an exploration that's in your book on page 109. So let's just pretend like we're doing this and we have a paper triangle in front of us. And what we want to do is we want to tear off each angle of that triangle. So I'm going to mark in red. So you're going to tear off each of these angles, and the vertices are marked in red. And what we want to do is take each vertex and line up the vertices so that they're all at the same point. And what we notice is an actual demonstration of the sum of the angles of a triangle equaling 180 degrees, which is the same as a straight line. Another neat thing we can do is explore the concept of exterior angles. So the exterior angle, let's define that. So notice angle C. The way you make an exterior angle is you extend one of the sides of a triangle. So we're extending line AC out all the way out through D. So this one marked here, this is the exterior angle to angle C. Okay, so we've got three interior angles, A, B, and C. Okay, and we're talking about the exterior angle to C, adjacent to C. So what you'll notice now is that if you tear off, again, you have already torn these off, so tear off angles A and B. Okay, get their vertices, line up all the vertices, okay, right on angle C, and what we notice is that angle C plus B plus A, they make a straight line. So sum is 180 degrees. So the remote exterior angle, the exterior angle is congruent to the two remote interior angles. We have three interior angles. A and B are called the remote interior angles. Okay, why? Because remote means away from. So they're the two that are far from the exterior angle. Okay, so the sum of the remote interior angles is the same as the exterior angle. That brings us to Theorem 18.1. Triangle sum theorem. You have known this since pre-algebra. The sum of the measures of the angles of a triangle is equal to 180 degrees. When we justify, we're going to use TS. So in example 1, let's read together. In the right triangle, triangle MNO, angle M is 45 degrees. All right, it says we have a right triangle, so we're going to have to draw this. So there we go. Drawn. There's my right triangle. And it tells me that angle O is 45 degrees. So let's take one of these that's not the 90 degree, call it O, label it 45 degrees. Find the measure of angle M if angle N is the right angle. All right, so we're going to have to label the right angle as N. And then we're going to find angle M, that must be this one here. So by the triangle sum theorem, we know that angle M must be what? Must be 45 degrees. A corollary to a theorem is a statement that follows directly from that theorem. The triangle sum theorem has several useful corollaries, so we're going to go over 4 of them right now. The triangle sum theory corollaries, the first one is if 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles are congruent. So talking about similar triangles, if we have 2 angles congruent, like so, then we know that that third angle must be congruent as well. And in Algebra 2, I don't know if you guys remember this, but this was when we said 2 angles congruent means 3 angles congruent. AA means AAA. Corollary 2, the acute angles of a right triangle are complementary. And so let me draw a triangle right here. Let me squeeze it in here. Right triangle. So because of the triangle sum theorem, we know if we have a right triangle, we've already taken care of 90 degrees. That means that the two acute angles, which are these right here, have to have a sum of 90 degrees. Corollary 3 is the measure of each angle of an equilateral triangle is 60 degrees. So equilateral triangle means equiangular. So 3 congruent angles, well, we've got 180 degrees total. Therefore, each one must be, well, let's see, 180 divided by 3 is 60. 60, 60, 60. The last one is a triangle could have at most one right or one obtuse angle. If I'm trying to draw triangles here, let's do this one first. At most one right angle. Okay, so let's start drawing a right triangle, starting with one right angle. There you go. All right, can you draw another right angle? Can I draw another right angle? Well, sure I can. Let's do it right here. Okay, well, problem, I've already got 3 sides. There's no way I can have a 3-sided figure with 2 right triangles, so that doesn't work. Okay, let's try the other one. It can have at most one obtuse angle. So let's start drawing a triangle here with one obtuse angle. Great. All right, can we draw another obtuse angle? Well, going from either end here, let's go to the right side, and drawing another obtuse angle. Yeah, that's a problem, isn't it? Because I've already got 3 sides, and there's no way that that third side is going to connect back to the first one. So that doesn't work either. You can have at most one right or one obtuse angle in a triangle. Okay, let's do a couple more problems. Example 2, find the measure of angle R in this triangle here, triangle PQR. All right, well, I don't have anything labeled, so this is all going to be just kind of in the general sense. Okay, I know I have a right triangle, so that tells me that the sum of the 2 acute angles in that triangle have to be a sum of 90, right? I don't know what they are, but I know that they're going to have to add up to 90, okay, to go with this other 90 to make 180 total. And that is that corollary, corollary 2, 18-1-2. Okay, that says the acute angles of a right triangle are going to be complementary. Okay, so how do we do this? We need to find angle R. We need to find angle R. So this is my question mark. Let's just start writing this out. So angle R plus angle P, they have to equal 90. All right, well, R is R, that's what we're solving for. Can we substitute in for P? Okay, so far we know that P is listed as Y. So let's just substitute that in there. And solving for R, we would subtract Y to both sides. And we're going to say that angle R is 90 minus Y, or 90 minus Y. We can put it in parentheses and put degrees. Okay, that's all we can say, 90 minus Y. Another one, in triangle JKP, the measure of angle J is twice the measure of angle K. Let's write that out, just a straight translation. J is 2K. Okay, let's do another one. And the measure of angle P is 3 times the measure of K. All right, let's write that. P is 3 times the measure of K. P equals 3K. Find the measure of each angle and name the right angle. Okay, guys, all we know is we have a triangle, so we know that the triangle sum theorem says that all of the angles are going to add up to 180 degrees. So let's start there. We can say that angle J plus angle P plus angle K from triangle JKP, right? They're going to add up to 180 degrees. Now let's simply substitute. So substitute in for J. From that green top line, we know J is 2K. We know from the second line, we can substitute for P being 3K. And check it out. Now we have a single equation with one variable. So how many K's do we have? We have 6K, that equals 180. Therefore, K is 180 divided by 6, or 30. All right, so it says find the measure of each angle and name the right angle. Okay, all right, so let's back substitute. Angle J is 2 times K, or 2 times 30. Angle J is 60 degrees. Back substitute in for P. P is 3K with a K of 30. Therefore, angle P is 90 degrees. Aha, that is the right angle. And K, that is one of the angles. That's 30 degrees. Let's check that and see if we got it right. Boom. Yes, we did. All right, on to the next one. So we already talked about this in the exploration, the exterior angle theorem. Oh, weird, I don't know why there's a big blob here. Okay, so here is your official theorem. It is numbered 18-2. It says the measure of each exterior angle of a right triangle is equal to the sum of the measures of its two remote interior angles. So the measure of angle DCA is equal to the sum of our two remote interior angles. Okay, so add those together. Example 3, find the measure of an exterior angle at the base of an isosceles triangle whose vertex angle measures 50 degrees. All right, well, we know that in any triangle, 180 degrees is our sum. If we have already used 50 degrees, we have a remainder of 130 degrees to share evenly or equally between our two base angles of our isosceles triangle. So therefore, we've got 65 degrees, 65 degrees. This is what we have to find, the measure of an exterior angle at the base. Okay, so I'm going to find this exterior angle here. Now, I know you guys could use supplementary angles. That's totally fine, but let's do it our new way. We know that this is a remote exterior, sorry, this is an exterior angle. Therefore, it's going to be equal to the sum of its two remote interior angles. Okay, so add those up. 50 and 65, so that's going to be 115 degrees. Okay, by the remote exterior angle theorem. All right, let's put an abbreviation there. So exterior angle theorem. Exterior angle theorem, you can put that, or you can put corollary what? Corollary, oh, no, that's actually a theorem. So that's one of the theorems. Yeah, theorem 18-2. Theorem 18-2, or just say EAT, exterior angle theorem. All right, in triangle ABC, two interior angles measure 54 and 62. Okay, we're gonna have to start drawing this out. I've got a triangle with a 54 degree angle and a 62 degree angle. Okay. I don't know, the order doesn't matter, I guess. 54, 62. Let's extend this up a little bit. Determine the measure of the exterior angle that is adjacent to the unknown angle. Okay, so let's go draw that in. Here's the unknown angle. So I'm going to complete that triangle. Extend the base. So the exterior angle that's adjacent to the unknown angle, that's this one right here marked. Okay, and so let's go find that. Okay, so take the sum of the two remote interior angles, add them up, 54 and 62. So that's going to be 116 by exterior angle theorem. And then find the measure of the unknown interior angle. Okay, so this one either by supplementary angles or by triangle sum, both of which have a sum of 180, 64 degrees. So SA with this one here or triangle sum. All right, let's finish with an application in civil engineering. A bridge uses cables to support its 2,000-foot span. Use the data in the image to determine the measure of the angle at the apex of the marked cable structure. Okay, so we are looking for angle 3. All right, looks like we've got an exterior angle. Okay, and we have two remote angles. So angle 1, angle 2, and angle 3. Notice those 3 angles in this blue triangle here. All right, so let's start by writing out an equation for what we know. We know that the exterior angle, angle 1, this one here, boom, is equal to the sum of its two remote interior angles. So equals the sum of angles 2 and 3. All right, and now can we substitute? Do we know what angle 1 is? We do, it's 140 degrees. Do we know what angle 2 is? We do, that's marked as 25 degrees. And so we're just going to be solving for angle 3. Therefore, after subtracting 25 from both sides, 150 degrees is the difference. So angle 3, 115 degrees. All right, let's take this extension problem. Another suspension bridge must be built with an exterior angle of 8x. The two remote interior angles are 6x plus 10 and x plus 5. What is the value of x and the measure of the exterior angle? All right, so it's basically the same. We're just going to look at this in terms of an algebra problem with some x's in here. So let me get a bigger screen here. All right, so I'm going to erase everything from before. And let's just pretend we've got the same diagram here. I think it's going to work out. Okay, so new color. All right, read together with me again. Another suspension bridge must be built with an exterior angle of 8x. Okay, so instead of 140, we're going to put in 8x. Okay, that exterior angle has to be 8x. All right, continue reading. The two remote interior angles, okay, that's angles 2 and 3, are going to be 6x plus 10. So let's just drop this in here. 6x plus 10 in degrees. And angle 2, let's erase that or scribble out the 25 and put x plus 5. So you see how it's going to work the same way? Start with the same equation, the same idea. The remote exterior angle, 1, is the sum of the two remote interiors, angles 2 plus angle 3. And now we just substitute. What's angle 1? 8x. What's angle 2? X plus 5. What's angle 3? 6x plus 10. See how now it's just an algebra problem? Okay. So combine up all your like terms on the right before you start moving things over. So we have 7x and 15. Okay, subtract 7x from both sides. And we have x is 15. Okay, so let's see if we answered all the questions. What is the value of x? Okay, so x is 15. And the measure of the exterior angle. Wants to know that too. Different color. So red. If the exterior angle is 8x, okay, and that's going to be, so angle 1, the exterior angle is 8 times 15, or 120 degrees. All right, lesson 18 in the books.